everybody. Let's give a warm welcome to Tim.
All right. Thank you. Thank you very much for the testing. It's nice to be here at Nerd. We're hoping to tell you something unusual that you probably have never heard of before. But today I'm going to be talking about hermaphroditic land snails having sex. And by the way, I'm going to be using biology terms. So biology terms apply to non-humans, okay? So don't take offense that I'm using the word hermaphrodite. All right, so today I'll give you an introduction in which we'll talk about a refresher on mollusks, just in case you don't remember your biology class. And we'll also talk about evolutionary biology. And here, the bottom line is passing your genes on to the next generation. Then we'll talk about sex. And most land snails are simultaneous hermaphrodites. That means they're male and female at the same time. And many of them can self-fertilize. Then we'll talk about wacky sex. So here, one of the things we'll be talking about is that the pouch that receives the sperm is a digestive gland. How does that make any sense? And also the role of darts during courtship and mating. And then we'll talk about even wackier sex. Here, some banana slugs chew their penis off after mating while it's still inserted, and sometimes they both participate in chewing it. How does that make any sense? And then, in some serial matings, sea slug A will give sperm to sea slug B, then sea slug B will give sperm to sea slug C, but sea slug B gives A's sperm to C. Doesn't even use his own sperm. So something weird has got to be going on. All right, that's the preview of what we're talking about. So first, let's go with the refresher on mollusks. So how do mollusks fit in with all of the other animals? We're going to take one of every species of animal. There's 8 million, somewhere between 8 million and 30 million species of animals, and we're going to divide them up into major groups called phyla, or phylum for singular. And there are about 35 to 40 phyla in the world, and mollusks is the second largest in number of species. The largest one are the arthropods. Most of them are insects, but they also include spiders and scorpions, things like that. Things with a hard exoskeleton and jointed legs. Those are the arthropods. The mollusk is number 2, and by the way, things with a backbone like us are only number 3. There are more kinds of mollusks than there are vertebrates. Yay, mollusks. Okay, then within the mollusks, here we're looking at just the things underneath this yellow bar. Within the mollusks, there are 8 classes. Class is the next level down under phylum. And you've heard of at least 3 of these classes. The ones that everybody knows about are the gastropods, the snails, the cephalopods, which would be the squids and the octopus, and then the bivalves, the clams and the oysters and scallops, things like that. Some of you might have heard about some of these other ones, but many people have not. I've got a list of features that these different groups have, and I know it's probably too small to read, but we will be talking about torsion as a uniting feature for the gastropods. All right, so in torsion, so here's your anatomy refresher. Torsion brings the anus over the head. So that snails are real poop heads. So in this cartoon, you can see that, so most animals do have their mouth in the front and their anus in the back, which is a good arrangement. I think that's a pretty good and mollusks have that too, and snails have that when they're really young, but then they do this thing called torsion. So the tan parts are the head, foot, and then the visceral mass is this peach-colored part. And when they're less than a week old, they're still inside the egg or floating in the plankton. The visceral mass twists around 180 degrees, and it brings the anus over the head. It also brings the gills and the genital core and some other sense organs and things like that. So torsion really does remain a mystery. Why do they do it? It probably makes sense that you want to have sense organs and other things up in the front, close to the head. But people really are not sure why they do it, but they do. All snails do this. And snails make up 80% of all mollusks. So then there's something called detorsion. So a lot of them will detort a little bit. And so then the anus and the genital pore and the breathing apparatus all ends up on the right side of the head. So for example, in this snail, you can see this little pimple here, this white pimple. That's actually the genital pore. So it's there on the right side of the head. In these two slugs, this is the breathing pore for these slugs. Oh, and in this snail, the anus and the breathing pore would be just right here underneath the shell. In the slug, the breathing pore is up here on the top, and the anus is right next to it. And so this slug down here is pooping. It looks like it's pooping out of its breathing pore, but it's not. It's pooping out the anus, which is just right next to the breathing pore. And then, so these are some examples of the escargot snails, the most commonly eaten escargot snail. And since the genital pore is on the right side of their heads, they're mating right sides of their heads together. And I see two penises. So it looks like they're each inserting a penis into the other. So the sperm is going both ways, and they're both going to get pregnant. All right, so now let's talk about sex. So yes, most land snails are simultaneous hermaphrodites. So that means that they are female and male at the same time. And many of them can self-fertilize. They do prefer to mate, to outcross, if they have a chance. But if they can't find anybody, they can. Many of them can fertilize their own eggs. And sometimes one will play male, one will play female. Other times they'll both play both. And so sometimes sperm goes one way, sometimes sperm goes both ways. And so they can both get pregnant. All right, let's talk about the plumbing inside there, the reproductive tract plumbing. So up here, this is near the top of the shell, near the top of the spiral, and here is on the right side of the head where the genital pore is. And so the ovotestis is this gland here. That makes both eggs and sperm, and they're going to both travel down the hermaphroditic duct. So this FP over here, that stands for fertilization pouch. From here, let's focus only on the sperms for a moment. So the sperms are going to travel down this groove and then up through the vas deferens. And now I'm going to get my my soft sculptured penis here for example. So right now, in this diagram, the penis is in the resting stage. But when it's business time, the penis is going to evert out that pore, and then. And by the way, I want to point out, I want you to notice this penial retractor muscle. That will be important later when it's time to pull it out. But this hand is now representing the vas deferens. So the vas deferens is down there at the tip of the penis, ready to go into the partner. So it goes into the vagina of the partner, and then it goes up into the bursa copulatrix. So that's the sac here. Then, when they're done mating, then the penis retractor muscle pulls the penis back in. So now the sperms then have to swim down or up along the duct of the bursa copulatrix and then up the ovotestis up to the fertilization pouch. And that's where fertilization happens. So the eggs are traveling down the hermaphroditic duct, and then the allosperm, the sperm from a partner, can fertilize the egg, and then the egg gets a bunch of albumin from the albumin gland, and then travels down the oviduct and out the vagina. Here's the only pun that I have in the whole talk. And that's how snails get laid. All right, so this is the same diagram, but now I want to talk about some of the wacky stuff that happens. And so before we talk about that, let me talk about evolutionary biology. So again, you want to pass your genes on to the next generation. And when I say want, I know I'm anthropomorphizing, but here's something to think about. Every organism that's alive today, they had ancestors who were successful at passing their genes on to right now. And the ancestors who didn't pass their genes on, they don't have any descendants alive today. So it's not really that they want to, but those who do pass their genes on are the ones who are represented. So I'm going to use a shorthand and say they want to pass their genes on. And so now So there's also the battle of the sexes, or male-female conflict. By that I mean if you're thinking about passing your genes on, well, it's really cheap to make sperm. I mean, it doesn't take a lot of resources. So males can produce a lot of sperm. So their strategy to get into the next generation might be fertilize or inseminate as many females as possible. But the females, they're producing eggs that are costly to produce. So they can't be promiscuous with them. They instead are going to be choosy. They want to choose the fittest male, because the fit male fertilizing her eggs is probably going to make fit offspring, and then they will be more successful in the future. So under this hypothesis, males, we would expect them to be promiscuous, and females, we would expect them to be choosy. Now, imagine you're a hermaphrodite. I want to be choosy. No, I want to be promiscuous. I want to be choosy. So it's a little bit of a conflict there. And we think that that might be why some of these weird plumbing things that I'm about to talk about have arisen. So for example, look at, what's that for? And, oh, right, I forgot to tell you. The bursa copulatrix turns out to be a digestive gland. What? So the one who's playing male is going to deposit the sperms in this bursa copulatrix. That's a digestive gland? That doesn't make any sense. And furthermore, there is peristalsis in the duct leading to the bursa copulatrix. Peristalsis is the waves that are like in your intestines. They're moving the food along through your intestines. So the peristalsis is moving the sperms back up into the bursa copulatrix. So the sperms that are trying to swim down so that they can go up to the first fertilization pouch, they're being pushed back up to be digested. So it must be really difficult for those sperms. Well, it could be, and I'm speculating at this point, but it could be that if this individual, the one who's playing female, likes the one who's playing male and thinks, this would be a good father for my eggs, maybe she can have the egg or have the sperm go up this diverticulum where it wouldn't be digested, and then she can use it later on. So that was speculation, but there's some evidence that that might be happening. A second thing is, see this D, that's a dart. And so there's a dart cell. And many snails use the dart during copulation. So it's before the insemination, so it's not delivering the sperm. This is a dart that happens during copulation. And the one who's playing male is the one who shoots the dart. And it's covered with mucus that contains pheromones or hormones that cause reverse peristalsis. Ooh, tricky, right? So it's reversing the peristalsis and then allowing the sperms to move down more easily. And so we think that it's a way for the one who's playing male to ensure or at least influence paternity. So it increases his chance of being the father of the eggs. So there are other weird adaptations, evolutionary adaptations in the anatomy, and we think that a lot of them might be explained by this male-female conflict. All right, now there's even wackier sex. So, like I mentioned, the banana slugs will chew their penis off after sex. And so up here, by the way, banana slugs live only on the West Coast, so we don't see them here. But here are a couple of banana slugs, and this is the penis. I'm not actually sure whose penis that one is. It looks like this one is chewing on the penis. And so the one whose penis gets chewed off will effectively become female. How does that make any sense? And then let's talk about this sperm trading. Sperm trading is a little bit like egg trading. So some tropical fish, some tropical fish are hermaphrodites, but they don't want their partner to cheat on them. So by cheating, if one of the fish lays all of its eggs and then the partner comes and fertilizes them and then runs off before this one has a chance to fertilize their eggs, that's cheating. So what they do is egg trading. So one will lay one egg and the partner comes over and fertilizes it. Then this one will lay one egg and the partner comes over and fertilizes it. And then they go back and forth. So sperm trading is not quite the same, but it's similar. So in this one, C slug A is going to give sperm to C slug B. So I've color-coded these sperm masses so we can keep track of them. But it's a reciprocal mating, so B is also going to fertilize A. Then B is going to turn around and mate with C slug C, and so C gives some sperm to C slug B, and then B mates with C, but B doesn't give his own sperm, or their own sperm. B gives the sperm that it received from A. So in terms of this trying to get your genes into the next generation idea, how does that make any sense? Because B's not even using its own sperm. So one way that we can make some sense out of this is to think about, if you are a hermaphrodite and you can choose which sex role to be, which one would you choose? So a lot of people think, oh, well, I would be the male because the male has a chance to inseminate lots of females, right? But what if none of those females use your sperm? Then you've lost. So it might be that the better sex role to be, if you have a choice, is the one who influences fertilization, and that's usually the female. So with these banana slugs, if the banana slug gets its penis chewed off, well, then the next time it mates, it says, oh yeah, I'd be happy to mate with you, but I have to be the female this time because I don't have a penis. And with these sea slugs, the sea slugs seem to be very happy to receive sperm, but they want the chance to give sperm, and then they also want a chance to choose which sperm that they're going to keep and use. All right, so in conclusion, most land slugs are, land snails and slugs are hermaphrodites. There's some wacky plumbing in the reproductive system, which might be a consequence of this male-female conflict happening within a single individual. And wacky behaviors like genital mutilation and sperm trading might reflect that the best role to be is the one who controls fertilization, and I think it might be the female. All right.